Whoa. That does nothing. All right, come on in. Lots of good seats. Well, I think we'll go ahead and get started, and hopefully some more folks will filter in. But thank you for joining us here this afternoon. I'm Josette Lewis, the Chief Scientific Officer for the Almond Board of California. So I work with a great team of folks who manage our research program. And today we're going to talk about some post-harvest research that we do, looking at how to add greater value to the almond biomass, or some of the co-products that we produce every year in the almond orchards. And I'm joined here today by two great speakers, Mark Privatera with Preprocess Inc. Mark is the CEO and principal engineer of Preprocess Inc. and has a background in chemical engineering, worked for the bulk of his career with large CPG companies, Clorox, Procter & Gamble, and then had a second career providing advice and consulting services to startup companies as well as established companies in product development. As well, I'm joined by Madison Garola, who is a food technology with Matson Foods, or Matson Co. For those of you who went to the lunch yesterday, you got to hear from the head of Matson and talking about food innovation. Madison brings a background specifically in upcycled food, so looking at the use of waste streams from the food processing industry and creating new value into food products. So great expertise to apply to our discussion here today. So I will put into little context why the Almond Board is funding research on biomass utilization. Hopefully that works. There we go. Look at that, Mark. I made you a CEO twice. I clearly did not look carefully at those slides. All right. So for those of you who grow almonds, this is probably not a big surprise, but if you're maybe on the processing or in the food side, the kernel, the part that we really value the most, is only a third of what comes out of an orchard every year. We have the hulls, the shells, and as you can see down there, the sticks. And at the end of the life of an orchard, after about 20, 25 years, we also have the entire tree, which is a co-product. So we have a lot of woody biomass in addition to an annual production of hulls and shells. And the reason the Almond Board got involved in looking at new uses of particularly hulls, shells, and sticks is several-fold. One is to add value. If you're a grower and you've been in this business for long enough, you probably didn't pay to have your almonds hulled and shelled say about 10 years ago, and now you do have to pay. So you're paying more and thus less in your pocket. The other reason is that we are producing larger volumes of co-products, and currently those products primarily go into the dairy industry. So the hulls go into dairy, largely the shells go as bedding. So hulls go into dairy feed, shells go into bedding. And then the sticks, if you're a huller or sheller, are a big problem. And you may end up, if you ever go by a huller, there will be large piles of sticks. And I was just talking to a huller this morning. I was manning the ABC booth. And he's invested in some of the most current technology on how to burn those cleanly and meet our air quality standards. But he has to be doing that year-round to get through a stick pile. Whoa, I'm going too fast here. So you can see here that our almond biomass is increasing as we hit 3 billion pounds. And those co-products are either going to end up driving down the prices that the dairy industry is willing to pay because we have more of it, supply and demand. Or if they're products that don't go into that, then we're going to have larger piles that we have to find some productive use and a use that meets the environmental standards here in the state. So if you're a grower, we want to add value so you don't have to pay as much for hulling and selling, and we want to make sure that those waste streams are going to profitable use, not things that are going to cost more money for all segments of the industry. Secondarily, what we've learned from doing 2 rounds of life cycle assessments is that this co-product utilization is a great asset to our industry in telling our sustainability story. So for certain, increasingly for food companies who are looking at what their carbon footprint is for their business, particularly if they're a multinational company, this thing seems to kind of move on its own. I'm going to put it down. I'll touch it. They're starting to look at the carbon footprint of their ingredients in addition to their own operations. The first time we did a life cycle assessment in 2015, and the life cycle assessment looks at the full carbon footprint of growing and processing almonds. And you can see there in that green circle there, that's credit. That's an offset or an inset. That's a credit we get on our carbon footprint because those co-products are going to productive use, displacing the need to create even more greenhouse gas emissions, for example, in growing dairy feed. So the use of our hulls means less crop has to be grown using nitrogen fertilizers and so forth. So that was a great part of our sustainability story and a unique value proposition of using almonds as an ingredient compared to many other products. That said, one of the biggest co-product opportunities that we had historically was the use of the trees in energy cogen facilities in the Central Valley. And with the loss of those cogen facilities, we lost some of that really great offset or carbon credit that we would get for co-product utilization. So again, we want to continue to maintain that positive attributes to, in addition to the quality of the kernel itself. And so finding more diverse and of some higher value uses will return more grower dollars back to you, in addition to continuing to have a great sustainability story for our industry and another asset to why food companies should use almonds as an ingredient. So those are sort of the motivators for why 5 years ago we initiated a research program specifically designed to look at more diversified uses of hulls, shells, and woody biomass. And this is a summary of that investment over the last 5 years, so just under $3 million. And probably can't read the details there, but we've looked at diversifying the use in animal feed, particularly poultry looks like a great opportunity. Increasing feed rations in the dairy industry for the hulls, using hulls as a soil amendment technique to deal with nematode problems in soils now that soil fumigants aren't as easy to use in the state of California. So can we use our co-products productively for that? We've looked at shells, torrefying shells as an addition to plastics, particularly to make the recycled plastics stronger. And using shells, biochar, as some of you may have heard of, as a soil amendment in and of itself. And then the wood, I think hopefully if you're a grower, you've heard about whole orchard recycling. This is pioneering almonds first technology where at the end of the life of the orchard, those trees can be chipped into small pieces and then deep ripped into the soil where they sequester significant amounts of carbon in the soil. A lot of that carbon that the tree was sequestering as it was growing are now returned deep into the soil, which that carbon is not just good sustainability story, but it increases yield by 19% and increases water holding capacity of that soil by 20%. So really good value proposition to the grower if you're going to replant another orchard by using whole orchard recycling. So that's a great way, now that we don't have cogen, to use the very large volume of woody biomass that we get at the end of the life of an orchard. So if you haven't heard about that technique, there's a great brochure that tells you all about how to do it and the value back to you down at the Almond booth at the end of the session or on our website. So that $2.7 million is to look at diversifying the use, to do the research to show what's technically feasible, to start understanding a little bit more about the composition of our products, to help us understand what might be the unique properties that could distinguish them in a marketplace where there's a lot of existing feedstocks and ingredients that we would be competing against. So in the last year, we've wanted to shift from the research showing there are some very viable opportunities. You can get food-grade ingredients, and we have one of our researchers here with us today from the University of Minnesota. There was a great poster down there to describe that research. If you pick up the research update book at our booth, you could also learn more about these. You can get very good food-grade ingredients out of hulls. Again, torrefied shells can be a very useful addition to plastics. So all that research showed what's technically feasible. But technically feasible doesn't mean there's more dollars back in your pocket or more dollars back in our industry. So we wanted to shift from thinking about this as a research program to saying, what can we, the Almond Board, do in a pre-competitive way to make these industries aware of that opportunity and to reduce the barriers or help uncover the value so that those industries outside of almonds will want to invest further commercially in taking new products to the market using almond hulls, shells, or woody biomass. And so what you'll hear today from Mark Privatera is that first analysis of all these very diverse market opportunities, which look like the best opportunity for almonds, where our products have some unique characteristics that distinguish themselves and also can compete on the cost and the price that's going to be part of any successful new uses of almond biomass. So I will let him describe what those recommended areas are that I give a little bit of a hint there on the slide. And where we will be going next is to, in those specific areas that look like the best opportunity, the Almond Board will continue to work with experts in these other industries to help put together materials that can educate those manufacturers about the value proposition, to show up at their industry conferences with booths on their expo floor so that they're aware of this, to develop prototype samples so that they can look at those in their formulations, to refine some of the financials to show that there is a good commercial investment opportunity, and to reduce some of the regulatory hurdles, particularly around the food-grade ingredient side of things. So I think we'll get into a little bit more of that with the panel. I would also note that here in the state of California, there are several of our state agencies that are very interested in what is often called a circular economy. How can we take the agricultural waste products or biomass materials, forest waste products as they look to reduce fire risk danger. There's a lot of woody biomass that's going to be coming out of our forests, and they're looking for opportunities to not only create value and jobs, but also to use that in a way that helps our state meet our climate goals and our environmental stewardship goals. So we hope that working with the Almond Alliance, we can also unleash some public investment in some of the higher cost opportunities that we'll talk about, particularly around the torrefaction or the heat treatment of any of the almond co-products that can be used in some of the product development. So again, ultimately our goal at the Almond Board isn't to develop new products, but to really do as much as we can to demonstrate there's a good value proposition here, to make sure the industries that could take advantage of that know about it, and to reduce the hurdles for commercial investment, and then ultimately let the private sector take it from there. So that's sort of the journey we're on, and I will turn it over to Mark to talk about the market assessment.
Thank you, Josette. This is the clicker, but I'm going to use this slide just to build a little bit. First of all, I might go through a lot of information quickly. So if that does occur and you have questions, of course, we'll have the question session, but I also have my colleague, Christina Borghese, in the back, and we'd love to talk to you afterwards if you need more detail or whatnot. On the journey from research to development and then commercialization, as you do a project, there's also the phases that you got research, development, and then in there that's not shown is engineering, construction, and all the business development of the various, or construction of the business processes. And then there's operationalization, or that's where you're booking the revenue. And you got to keep your mind on get to revenue, that'll get you to profit, that'll get you the return. And whether we work in corporate or entrepreneurial world, that's always the rule. Do it legally, do it safely, do it ethically, do it with an environmental stewardship, but you got to get to revenue, you got to get to profit, you got to get to return. So that's kind of the mindset that we looked at this, because the first thing you have to do is figure out what's going to generate revenue. Are you going to generate enough revenue to support the operating expense, to give you that margin, and to allow you to invest the capital to give the return to the folks that are backing you, or if you're backing yourself. And the rules are very similar, whether it's corporate America or whether it's entrepreneurial America. Entrepreneurial America, of course, in the high-risk things, they want more return. But, you know, there's a certain ROI, there's a certain NPV, there's certain financial metrics that you always have to meet. So the first piece of that is what kind of revenue can you generate? So keep that in mind, because that's one of the criteria that I'm going to show you here in a minute that we went through to determine our recommendations on, hey, you might want to try doing this with the hulls, shells, and the woody biomass. All right, I hit the right button. When we looked at this, all the different products, there's 3 platforms that fall out. Now, a platform is a processing grouping of unit operations that usually can convert something to something else. Okay, that's where you can add value, all right? Sorting, you guys do this all the time. Physically, you remove the sticks. Physically, you remove the shells. Physically, you remove the hulls. You have the kernels. So you're very familiar with sorting. And there's unit operations, right? There's shakers, there's air separators, whatnot. Maybe one of the platforms to build upon is the physical work and increasing the quality or separating out a greater volume. The next platform is now a chemical operations platform, extraction. There are certain constituents that are in the hull, the shell, and the wood that can be extracted for their unique value. And I say unique on purpose. If you're just extracting a commodity, it's a low-cost thing, okay? So wood, is almond wood so unique to somebody who's firing a cogen versus other types of woods? Maybe not. Is almond wood unique in the entertainment? And remember, charcoal, commercial charcoal is entertainment, right? I mean, not overseas, but in America, in California. So is almond wood something folks would want to have on their backyard barbecue as opposed to something else? Maybe, maybe. Now, chemical extraction, there are some phytochemicals, there are sugars, there are fibers. All these have value. Fiber. Fiber can, in the diet of Americans, we eat too much protein, not enough fiber. Soluble fiber and insoluble fiber. The hull is a great source of both types of fiber. Can you extract that fiber and present to the consumer a compelling food product built on that message? Torrefaction. And these cascade. You sort the highest value out, you then extract the highest value out, and nothing's 100%. You always have some sort of separation factor, 80-20, 60-40-40, or 60-20-20, whatever it is. So now these can feed into each other. Torrefaction is a thermal process. There are 5 common thermal processes in chemical engineering. Torrefaction is the lowest temperature and the lowest pressure, okay? So what happens is you get a different set of materials from torrefaction than you get if you went all the way to the 5th one, which is pyrolysis. Pyrolysis is where you turn everything into a gas. That's kind of what was happening for a long time with your wood, right? With the gasification plants or with the cogen plants. They wanted gasified feedstock so it would burn in the turbine, all right? But there's some other things you can make from a torrefied material. Carbon. Now this is where there's a lot of confusion. When you talk carbon, we're breathing CO2. There's 400 ppm of CO2 going in and out of us every time we breathe, right? Used to be 200, right? 200 ppm in 1900. Right now it's 400. That's what's got everybody, that's the whole thing with climate change, right? That's why we're trying to sequester that carbon. You take that carbon, have the tree, pull it out of the atmosphere. It's now in the hull, the shell, the woody. If you take that and turn it into a useful byproduct and use that carbon in a different way besides just burning it and hitting CO2 back into the atmosphere, that's a sustainability story. Carbon out of the atmosphere by the tree, processed into a set of products that keep the carbon sequestered, and it's useful, therefore has value, profit, return. You guys kind of with me so far? That's how the products kind of line up when you platform them. Now, the simplest thing to take away from this slide is there's a sorting plant, there's an extraction plant, there's a torrefaction plant. Similar type unit operations, different types of operations on the material that gives you different products. Could all of them be in one place? Absolutely. Do they all need to be in one place? Not necessarily. Are the capital investment different for each one? Absolutely. All right, some things to think about when you talk value versus effort. All right, and this is just a simple little graph of, all right, if you've got a pharmaceutical active ingredient, an API, that you can extract from a naturally derived source. The latest one that's been in the news the last 5 years is cannabidiol from hemp. It's a pharmaceutical grade extract, unbelievable value, right? So that's the example. We're going to keep looking. Everybody's going to keep looking. Haven't found exactly a pharmaceutical grade extract out of any part of the almond yet. There could be one. Vitamin E is an extract. It's not a pharmaceutical extract, but it's a nutraceutical. Close. The next value is human food. Fiber. In the hull, there's a lot of fiber. In the hull, there's a lot of sugar. In the kernel, well, we've heard how nutritious the kernel is. You guys know that. Animal feed. Okay, you know that story. Consumer non-food. Then you get into industrial specialty and industrial commodity. Is it worth investing in another commodity? Well, maybe. If you're a low-cost producer, absolutely. But you're fighting on low-cost production versus being unique. So there's a couple of words, right, that I want you to leave this session with, right? Revenue, profit, return. I think those are always on our minds, right? Not that we're all, we also think of the other things that are important. But unique. You have to identify something that's unique. That way, you have a claim that you can defend. You can patent uniqueness. You can also put up barriers to entry with uniqueness. That gives you more sustainable economics because you don't have to fight. It doesn't turn into a commodity. New market development versus a competitive displacement. To build a market is a huge undertaking. To displace a competitor, that's tough too. It's a different set of skills, right? Very different set of skills. A lot of education on both sides. Competitive displacement, you have a lot of headwind. New market development, you have a lot of headwind because it's an unknown. Functional value versus lowest cost. I mentioned that with uniqueness. The incumbent use. Incumbents know what they need. Supply chains might not even know that almond hull has this possibility. Food scientists, food developers, plastics manufacturers, they might not know the value in hull carbon. What is the motivation? If you're displacing an incumbent, there's going to be exit dynamics. you know, a lot of pricing, a lot of contracts, a lot of undercutting, right? A lot of business things to protect that position. Versus what's the new market motivation? Fiber, healthy fiber. They're flying off the shelves. The food, it's the new thing, right? Or cosmetic. Boy, that moisturizer. I was on the Oprah show and look at how good my skin is, you know, from that moisturizer. That also happens to carry all the goodness of the almond kernel for my skin. Feature differentiation versus, same supplier or same spec, different supplier. All of these things you have to look at for value to effort. One product, if we took this all the way to not only torrefaction, but turn the syngas into something, an easy drop-in into a massive market, the petrochem feedstock market, because they're looking for green, renewable, sustainable, circular economy answers. And your stakeholder turmoil or stomach for turmoil, because when you do a new thing, there's going to be a lot of ups and downs. Not everything's going to go great, right? We've done 8 probably over the last 10 years. Some in the entrepreneurial world, some in the corporate world. Always have problems, always. It's just how you manage those problems and get through them is what makes you successful. Here is what we've recommended. Now, I want to explain something. Look at that FEL2. What is that? All right. In research, development, now engineering, construction, and operationalization, everything overlaps. And there's methods to stage gate or keep on track. From the 60s, there's this method called front-end engineering development, FEED. Used to be called front-end loading, FEL. There's 3 phases, FEL 1, 2, and 3. Why am I pointing this out? It gives you, if you looked it up or dialed it on your internet, it gives you a metrics of how good is this information. We're at FEL 1 right now, opportunity assessment. You throw a wide net, you come up with a criteria based on factors. Means you look at reports, you do a little work here and there, you do some math, you go, I found something this big and it costs this much. I need to match it with this big and this much. And you use factors to come up with the numbers. We're at FEL 1. FEL 1 means we're plus or minus 100%. That's terrible. It could be $2, you mean it could be $2 and it could be 0 or $4? Yeah, that's where we are. FEL 1, AACE, American Association of Cost Engineers, a level 5 estimate. To get to FEL 2, which is 30%, plus or minus 30%, is the next step. You refine everything, you validate things, you make prototypes, you do more math, you talk to more people, you look at more reports, you do some ethnographies. And ethnography is where you get a group of consumers or customers together and say, hey, here's a thing, what do you think about it? Oh, that tastes terrible. Or here's a thing I'm putting in your plastic. You know, oh no, it made it all smell like barbecue smoke or whatever, right? That's an ethnography. For FEL 2, it's 30%. FEL 1 is 10%. That's usually where you then go to the financial folks and go, look, I've got something here. So FEL 3 gives you that level, plus or minus 10%. That's usually the funding decision-making level. So when you do this type of work, we're at opportunity development. To get to FEL 2, that's specific project development. And then FEL 3 is project appropriation. All right, so that explains FEL 2. The animal feed is great with the animal feed. Keep going. The internal recycle of the chipped wood, great idea. Keep going. No issues there. Now, food. Turn the hull into a food. Oh, that hull. Have you ever seen the hulls? Yeah. Yes, they're dirty. Yes. Aflatoxin. Yes. Have to work all those issues. No question about it. But it's got sugar and fiber. Build a story on sugar and fiber. What's an easy way to do it? Nutrition bar. $1.50, easy to make, put chocolate chips around it, put some almonds around it, kernels around it, put some whatever, right? Test the consumer. It's easy. It's quick. You can get quick feedback. And Madison and Mattson, I'm sure you'll go into a little bit more of how that can happen. One thing the board, or as an industry that has to happen, you have to prove that the ingredient you're giving the food scientists to create these products is safe. It's called generally regarded as safe, GRAS. And you have to create a dossier, a packet of information that's peer reviewed, reviewed by regulatory agencies to say, yes, the way you've defined this food ingredient, we regard as safe. If you don't do that, then you have to submit specific formulations for individual evaluation. So as an industry, if you establish that hull processed in this way, heated up or water cleaned to get all the sticks removed, particle-size distribution, whatever, you could submit a GRAS dossier. Cosmetic moisturizer. The fiber holds water. Water on skin is a good thing, right? Yes. Skin health from eating almond kernels, absolutely, no question. But moisturizing, right? Maybe we've got something there. Activated carbon. Activated carbon is one of the biggest materials in volume that's used for water treatment. It all comes from overseas, okay? Think of the story here. We have 1/6 of the United States population in the state of California, right? Every town is connected to a water treatment, right? Potable water. They all use activated carbon. What if we had a sustainability, a circular economy story about, hey, we're using almond hull carbon instead of overseas carbon? All of a sudden, we're not moving that from overseas, and we have our own. And would we displace supply? Yes. But the rest of the world's growing too. So there's plenty of room for. Carbon's supposed to grow about 20% a year, by the way, just so you know. Plus, there's retail activated carbon. A company right here in California makes brittle water filters. If you ever cut open a brittle water filter, it's activated carbon and a resin. Okay? And then carbon black. Carbon black is in all the plastics. These are metal chairs, but it's a polymer. I'm sure it's a polymer coating. There's carbon black in it. Carbon black in your tires. Carbon black in most. It's a filler because you can't afford. We can't, as a society, afford to have all the chemical in the polymers and the plastic parts be only that chemical. It has to have a filler. Carbon black is one of the biggest fillers. Now, how did we get here? All right. This is the meat. We took and we did some math. We set up a model, and we took the value chain. We started from what will somebody give us for this product? $1.50. That's carbon. Let me go to the whole bar. $1.50 for a 60-gram bar. You can go outside any store and you'll see this, right? And then you strip out all the costs: retail markup, wholesale, legal support, regulatory support, the manufacturing costs, the transportation costs. So you start and you normalize it to a weight. Okay? Well, you can see quick here that back all the way to the piles that the growers own at the Holy Shellers, this one could possibly still have $600 worth of value per ton. Now, will you get all that? No, because over the development, things will change, contracts have to be negotiated, things are refined. And remember, we're at FEL 1, right? So my number could be way off. That could be $1,200, could be zero, all right? But we needed some way to normalize all the possibilities. So we used the same methodology, and we consulted papers and people, and we had discussions, and we've done this for many, many different products. So our methodology is not 100%, but it works. All right, hopefully this goes backwards. Yes. So what we did is we took that and we assigned, if the number came out to be less than 0, we gave it a 0. If the number turned out to be less than $200 a ton, we gave it a 1. 200 to 400, we gave it a 2. Over 400, we gave it a 3. All right. But that's not the only story. What's the effort to implement? some of these are high capital, some of these are high regulatory, some of these are very difficult technologically. So we've done a lot of different things in a lot of different industries, so we got together with some of our colleagues and we go, how hard do you think this one is? And we looked and we kind of validated it, right? Some are easy, some are not so easy. And remember, we're at FEL 1 level. What do we think the value stability is going to be over time? Is somebody going to be able to come in and drive us to commodity pricing? Possible. Are we going to have enough uniqueness to where the value is going to be stable? Then what's the potential growth? We looked at the growth of the markets. You can look at growth of markets, all these markets pretty easily. Whether you subscribe to an in-depth report, or whether you call a few buddies that are in those markets, or whether you look at what's the public domain information. There's a lot of studies. There's a lot of great studies on market sizing and market development. So what we did was we then multiplied them together. All right? So 1, 2, 3, and then the multiplicative total, and then the last is what's the most likely uptake? Is it hulls? Is it shells? Is it woody? Right? This is the summary. And you can see some of the things we looked at. I don't have a pointer, I don't think. No? AV guys? Do I have a pointer up here? No. Okay. Increased hulls to animal feed, industrial sorbent, soil amendments, animal bedding. You can see the list. And then these slides are available in about a week or so, right? So, and again, we can talk to you about more details. Oh, I'm really all for the shell blast media. What are you talking about that? We can talk about that. Now, some first entries. There's always the why this and not that. So I just wanted to discuss a little bit, why would we go with charcoal and not cat litter for an entry? Well, think about this for a second. If you own the brand, you control the value. If you're just an ingredient, the brand owner really controls the value, right? Because the brand owner's job, and I've been a brand owner, so brand owner's job is to produce that product at the lowest possible cost. That means suppliers, or brand owners negotiate with suppliers to get the most economically favorable contract for that material that you can get, right? Okay. Cat litter's got a lot of competition. There's 3 big players. Well, one of them, some of you guys are working with, and it's good, but just keep that in mind, right? And that might be something you want to pursue versus charcoal. Charcoal is an entertainment product. It's actually made by the same company that the cat litter made in California. And I made charcoal for a long time. So now in the United States, maybe an almond premium charcoal, that has some value. But just as a raw material, like I think you guys know that you used to sell almond wood to the company I'm talking about when they had a plant here in Sacramento. Actually, it was a little south of Sacramento. But does that hold the value? I don't know. Retail versus industrial water treatment. Retail is Brita filters or pure filters, Procter & Gamble or Clorox. Water treatment, slow market. A lot of sales cycle, a lot of education on the industrial. Chip wood you guys know about. Now food product versus a food ingredient. Food ingredient gives you the platform to expand upon. A food product that you own lets you capture all the value. A food product, and the reason we're saying the whole bar as one of the first entries, also gives you some insight into the concepts that you could own to then maybe you can develop out a food ingredient. Pulp is big one. Nanocellulose is going to be a big deal here in the next 10 years, right, from a chemical engineering standpoint. Pulp is the first step in getting a nanocellulose. You have a cellulose. These are all cellulosic materials. So from a chemical engineering standpoint, it's like, wow. And if you look up some nanocellulose, it's not quite ready yet for prime time, but it's getting there. Cosmetic. Am I running late?
Yeah, you're good.
Cosmetic. This is some of the things that we wanted to show this example. I know it's an eye chart, it's a lot to read, but this is some of the detailed concepts that you have to take into consideration when you're going to develop a product and try to put it on one page. It's impossible, right? Product development is an iterative to be right. I mean, beautiful. I mean, yesterday's lunch, phenomenal presentation, I thought, on how all those pieces need to come together to show some value, right, in food products. I already alluded to the different spreadsheets that we use. This gives you a little bit different view of how some of the numbers change. Like this is carbon, commodity value product. So this is commodity grade carbon, which it sells for less than this too. It can be as low as 20 cents a pound. We use $1.50 a pound because there is a grade in there that does sell for that. But there's also grades of carbon. Oops. Oh, I took the price down. I forgot. There's also grades of carbon that sell for $16 a pound, right? It depends how far you want to take that quality and how far you want to take that process. The whole bar I showed, and then the cosmetic is about 400. Now, for all these that are on this chart, we have the engine, the model behind it that generated those value numbers. Now, were we correct on all of them? No. Will they change over time? Yep. But we try to do as best we can the same basis so that you look at the spread of products that have come out of research or product possibilities that can be identified out of the research that's been done to see which ones you might want to pursue. And back on Josette's slides, you'll see keep doing the animal feed, and then nutritional bar, a cosmetic, carbon black, and activated carbon are the ones that we are recommending.
Thank you. All right, so we're going to, thank you. Yeah, and just to finish off, in terms of the Almond Board, our investment is in that box in the middle there to educate manufacturers, prototype, refine the financials, and so forth. And as we do that to get from, as he explained, FEL1 to FEL2, to increase the certainty of the economics and the how-to, we also will find out, maybe as we refine those financials, some of these don't seem to be quite as attractive, or we talk to a bunch of people in the cosmetic industry and they're not really interested. So we can always circle back into the research portfolio and pick up some of those other opportunities that weren't in the first wave. So that's sort of the journey we're on in terms of the Almond Board's investment to try to educate and uncover these market opportunities. So we're going to turn now to more of a discussion, and then if you have questions, we'd love to open it up to the audience to answer any questions you have. But just to get us started, turn to you, Madison. You have a lot of experience now with upcycled foods, kind of an area of specialization. If you could talk a little bit more about some of those major steps in trying to develop a food product, timelines, and maybe some examples from your own experience.
Yeah, definitely. So what I think is important here is to understand a bit of background and context for Matson, where I work. So we are a 44-year-old research, development, and innovation company based in the food area that specializes in food and beverage products across all categories, channels, and services. So we have a lot of expertise in breadth and depth. And I think that's important because we look at everything from front-end innovation to concept creation, talking about that nutritional bar, prototyping it, doing full product development, consumer insights on how that product is actually performing, and then commercializing it. And my experience so far in the upcycled space provides a really unique one and something different than our traditional innovation path. And that's because we have these new challenges because these are novel ingredients, one. Two, consumer perceptions of those ingredients. We honestly don't know what consumers are going to perceive. And so with this combined kind of learnings, we have to build a holistic approach to developing a successful product. And there's many ways to do that goes in an ebb and flow development. So I really appreciate that we're looping back this research and development cycle to bring the best ingredient or product to market. And we have experience, and I have experience with this really heavily in just new ingredients that come to our doorstep daily, and specifically want to talk about a novel protein that we've used. And for this protein, our client came to us. It's a really great sustainability story behind it. They brought it to our attention and said, here's what we got. We want to look at it in this application. And so our approach is first technical. And when we follow up with technical, we want to make sure we're tapping not into just one specific category, but doing a full screening, not only with our technologists, but also with our client managers, and finding an assessment on maybe our client sees this as having an opportunity, but what might they be missing? And how do we both deep dive in that area and also explore potentially other areas of opportunity? Once we do that, we like to look at the actual properties. As Mark talked about, it needs to get to a place where food scientists, whether you're developing it internally or you're looking to sell this externally, can actually use this ingredient as a tool in their workhorse. And you want them to think of this as something that's beneficial and that they want to deliver that fiber. If you have a 50% blend of soluble and insoluble material here, and I'm looking for a fiber source, it's from almonds, it has a great story, and it's free from, clean label, fits with my ingredient statement profile already, I want to use that ingredient. But if it has off texture, off flavor, isn't quite going into my system correctly, it's a hurdle. So part of our role at Matson is to really understand, one, where your ingredient is today and how we're getting you to that end application. Two, what can we do a year from now, 2 years from now? For this protein, for instance, it has a gray dark color. Maybe a vanilla ice cream for a high protein ice cream isn't going to be the space you want to play in. We're going to look at chocolate applications. Cool, let's look at a high protein beverage. Suddenly it's foaming. That's unacceptable commercially speaking. Okay, what can we do? We're going to make it heavier. We're going to lecithinate it. Suddenly you have a brand new category. On the flip side, foaming is great in ice cream. Maybe this chocolate ice cream is really want to be playing because we're getting higher overrun and you're getting higher yield and more value from that product. So it's really important to come at it, one, with both this focused approach on where are we delivering these benefits, but also not to keep your eyes so narrowed on the scope that you're closing out other potential opportunities. And with that, we like to really tap into, once we have something that we think tastes good, functionally performs, and we see a line of sight to, consumers. Put it in front of them. If they can taste it, awesome. If they just need a starting point of giving a concept and how would you feel about eating this, knowing it delivers this nutritional profile to you, that works as well, and we can get to the tasting point as our next step. But we need to build out this full platform and approach, and it does take time, and there's certain pathways that you can execute faster just due to inherent processing or kind of final product formats, and other ones are probably longer. But that's where Mark was talking about, you can have ownership. If you start with one small brand product that you're launching, we're not just going to recommend that your protein's going into this bar, because you should start there. But your protein is also going to be a ready-to-mix powder, a ready-to-drink beverage. We want to incorporate all of that with the great sustainability story coming to the table and executing against that. And then you can sell it to other manufacturers, get it into other categories, and really expand the breadth and thus your value of this ingredient.
Great. So you actually touched on a few different value components, particularly in the food arena. So you've got nutrition, taste, cost, and then the sustainability story. And I wonder if you could talk, both of you, a little bit more about which of those actually kind of most affects decisions on whether or not to use something, and whether, from what you know, there's really something in there for almond hulls.
Yeah, there's one answer that's going to, whenever you're getting it across the finish line, going to be your deal maker, and that's taste. Taste is king. It has to taste good for the consumers to succeed. Before that, there's different approaches. You can have your sustainability story driving it, but really who's going to purchase it and what the consumer is going to do is look at the back of the panel, see the nutritional benefits, see those claims front of pack, and then they're going to go, oh, wow, this also helps the planet? Great. So priority, definitely taste has to be there, nutrition, health for the consumer, and then we're looking at health for the planet in the third ranking.
Yeah, from my perspective, I completely agree with you. Taste is everything, and the stories that you can build on sustainability and whatnot. But I will add another thing that adds value. It's supply chain and supply assurance and the ability to manufacture. I've been, luckily, part of where you go to Walmart and you sell a big order, well, you better deliver, or else your product goes and then so.
Yeah, yeah. So looking at volumes, even though we think we have a lot of volumes, we need to make sure the volumes is adequate, right? Great. So again, kind of thinking about the food side, clearly the cleanliness, the purity of the starting product, and the uniformity can be factors. Could you talk a little bit more about that? I mean, obviously, in the context of hulls, if we have any huller and shellers out there, thing that I hear every time, and that is something we always have to keep in mind, is that getting to a higher quality starting product at the huller and sheller level is expensive. And so any kind of improvements that they would need to make have to be justified by a greater return on investment. But it sounded like you also thought there's maybe opportunities for intermediary industries to develop. If you could talk, both of you, about that, how important and how to get to the different types of ways to get to the kind of quality and purity and uniformity of the ingredient for any, in this case, food, or even any some of the other applications that you talked about, Mark.
Yeah, this is like being a kid in a candy shop for a chemical engineer, right? Take a pile of stuff that's dirty, that has value, and have to turn it into something pure, right on, bring it, right? I mean, every chemical engineer in the country should be like after projects like that, because that's the fun, right? But you do have to do that. And there are tricks that you have to take the dirty, moldy, stick-filled, dry, pockets of moisture, hard to handle, whatever, right, from the ag field or a stockpile, right, and bring it to an ingredient that you all being food scientists would say, yes, this is safe, this has clean specification, and I can start building products on it. That's where chemical engineers love to mess with food scientists. I mean, in a good way, Anyway.
Yeah, and from the food ingredient, that standpoint, there's kind of two things that come to mind for me. First is it is important that it is safe. If you tell us it's safe, that's great. We need to see it on paper, because we're also consuming so much of it through our development. I like my coworkers. I'd like them to all stick around. Second is the product really needs to be consistent. We had one of our clients, amazing client, they decided to switch processing on their protein, didn't tell us, sent it to us, and it was a completely different product. We could not do a one-to-one swap. They even had different protein content. So basically all of our work that we had just spent the last 3 months on was put on pause until we could align on what the actual stream is. And if you're trying to sell this to someone, imagine if you go to the store, you're going to bake a pie, you buy your flour, and suddenly your flour is milled to a different size. You're not going to be happy. Same exact when you're going industrial and when you're looking at selling thousands of tons of this material, hundreds of thousands of tons of this. You need to have consistency. You need to make sure that it's safe. But to your point, it is an evolution. Think of plant proteins where pea and soy was 5-10 years ago. It was not palatable. It was bitter, astringent. It's not the same quality product that we have today. It's not the same level that we can now put into vanilla sweet protein beverages. That wouldn't pass back then. You had to find applications that fit. So this is an evolution. We have some applications that you can put in, hide some of the off notes until you get to the point that it's clean enough to get to those more refined profile sensory experiences. Or along the way, maybe some of those off notes are actual positive notes, and you're bringing a new sensory profile taste benefit that the consumer didn't even know that they were missing because they'd never seen it before.
I always like to remind ourselves that the hull is the equivalent of the peach that we all enjoy. So there must have been some good stuff in there at some point we can bring back out. So as we think about any of these opportunities and sort of what we, the Almond Board, might invest in to help educate those manufacturers. There's really two basic kinds of manufacturers we're looking at. Established companies, the big CPGs or food brands, but then also the startup companies. And you both have had experience with both flavors. I wonder if you could talk a little bit about some of the differences and the opportunities and constraints of working with different kinds of companies that we would need to think about as we try to develop the right kind of materials and information to reduce the risks to either one of those.
All right. Two different kind of beasts you're dealing with potentially. Startups. Initial gut reaction is if it's a startup, they are building their brand and that brand proposition. Your ingredient is part of that core propositional message. That's why they want to include you. They're building their baby from the ground up, so they want to incorporate everything that will have that succeed. If you're going to an established company, they're already trusted by the consumer. They could have that consumer acceptance, and your ingredient could be a portion to a larger story that they're building. So it's almost not as Almond Hall in the front shining star, but you're going to get the utilization, potentially larger volumes, and already gain that consumer trust that can be a huge hurdle with some of these new novel categories, upcycled foods in the last year. It's been growing substantially because of things like the Upcycled Food Association, getting consumer education out there, but it is a hurdle. Food, waste, icky term, consumers don't like it. That's why it's upcycled now. So how do we deliver it? Either approach. Your startup is going to be your star and really deliver that as a driving key for their brand, or your established company is going to incorporate it and have it be a broader sustainability message that their consumer already trusts, can eat it and maybe not even do a second look at it, or look at the ingredient label and go, wonder what that is, look into the story, see the benefits.
So have worked and started up 5 and 3, worked for 5, started up 3, and worked for 3 major corporations. Here's my take on the difference. Check the backing of the startups. That's the key. Startups have got to make sure the investors are happy every day. That's all the CEO's job is to make sure they're happy, right? And to get more money from the investors. What that means is they want things fast. There might not be processes, workflow processes, and I'm not saying that you need workflow processes, but you need somebody who knows that there's a workflow processes, that when you get to the regulatory and or the data analysis needs, it's not just thrown to the wind like a lot of startups might do. So check who's backing up the startups. Very fast, very loose. That's okay with 2 guys or 2 gals, or 2 guys, a gal, or whatever, and a laptop. It's not so good when you're feeding something to people that have to meet regulatory requirements. But it works. It works. Corporate, you have to know how to negotiate the embedded workflows in the corporation. Corporations, if they're successful and have successful brands, have very, very strong workflow processes. There's whole departments that just make sure that stage gating is such and decision making is such. So might be fast and loose on the startup. If they've got backers that kind of like, we let them go, but we're watching that they're following process, sort of. Then on the corporate side, it's like you have to learn what makes their workflow, or else you'll get stuck. You'll get stuck at level 13,
That's really helpful as we think about, again, kind of what additional information and how we package it to keep that in mind, the different needs of each of those. So maybe just kind of a last thing before we open it up to any comments or questions you all have is maybe to turn to you, Mark, on the torrefaction. So this is the platform that perhaps has the greatest volume capacity, can take any of our feedstocks, any of our biomass co-products, but is also the really big ticket investment that's needed. I wonder if you could talk just a little bit more about scale, timelines, and kind of set up this as an area where perhaps what we're really looking at is going for unleashing some public investment in addition to setting the stage for private investment.
Sure. So torrefaction is heating things up without any oxygen. Okay, and I mean heating them up. 500 C for the preheat, 1000 C for the conversion, okay, with no oxygen. All right, so remember, when you make a fire, right, when you're burning things, you oxidize. It's just rapid oxidation, right? All right, no oxygen. On a demonstration scale, it would look like a silo of material about as big as that screen, that area. It would drop into a conveyor that would come over to this table. This would be the length of an extruder, a screw, an auger, right? So it's a screw that's under pressure. That's all an extruder is. And it's hot. That's where the heat is, okay? And you'd have your material drop in this end, and it would start converting here, about here, and somewhere here we take the gas off, and we'd have to catch the gas and make a decision. Are we going to turn and burn it? Meaning, are we going to use that fuel gas to heat the screw with some burner over here, right? Or are we going to take that gas, clean it up, put it over a catalyst, and make a high-value feedstock for the petroleum industry? That's what the chemical engineer and me would want to do, right? Then out that end would drop the carbon. Then down there you'd have another bin full of carbon, and then you'd go through a cleaning process that would probably take from, that row of chairs, where you'd run it through some caustic and run it through some acid. You'd dry it, you'd grind it, and that's where you'd have a carbon black. Now with that carbon black along the back of the room, you'd run it through some screeners, just like you guys use. You got Sweecos and Rotaps down there, or Ropax down there. So you'd run it through some screeners. Then you'd hit it with some steam, and you'd activate it. Think of how many products we just made, right? This, what I described, it would fit in this room, a ton an hour, okay? That's a super sack an hour, very small. Now, if you drive to any of the towns that have a medium-sized refinery, right? Medium-sized refinery in the state of California is 100,000 barrels a day, all right? If you took all of the hull and shell and did the math, you'd be processing the equivalent of about half what that refinery could process. So you'd be half the size of a refinery. So if you're driving to San Francisco and you go to the Unocal refinery, I used to work there. So that's about a 50,000 barrel a day, or back when, this was 40 years ago when I worked there. It was 50,000 barrels a day. The process for torrefaction for everything. Now here's an interesting thing. The Contra Costa refineries are shutting down their petroleum. They want to go to green energy, right? Talking to people about this. Wouldn't it be interesting, I'll leave you with this on torrefaction, wouldn't it be interesting if we figured a way to get the almonds, barge them, whatever, the almond hulls, to some assets that were decommissioned, repurposed, and all of a sudden we're feeding almond hull into the converted Contra Costa refineries that's kicking out high-value synthetic wax.
There we go. So we need some good data that we can share with our friends in the Almond Alliance, to share with our friends in the state government on that. Thank you. Well, that's the materials that we prepared for the discussion, but I'd love to see if there's any questions or comments in the audience before we unleash you. Yes, in the back. Mm-hmm.
So I think as you look to this, I think it might be good when this is constructed, what uniquely does the nut bring to the environment, and where can you find commercial use or local use that actually replicates that natural thing? So obviously everything you teach is common, right? And so then I'm thinking about, like, one of the feedstocks is microbes.
Mm-hmm.
And how maybe there's something we look at what the natural, how nuts exist in nature and see if there's commercial application and do that with a constraints of carbon footprint efficiency. So is it that, nuts, the whole, is it the bird that gets a nut instead of the whole, or does the whole bird provides some purpose? Can holes be used as a medium to apply, like liquid fertilizer to spread, Basically, just run it through the constraint of what nuts bring to a natural environment
Mm-hmm.
and see if there's a local purpose.
Mm-hmm.
And then look at it not only from a commercial point of view, but from a multi-benefit point of view. So I'm thinking, like, can we take a certain part of byproduct and dump it in the rice fields in the floodplain, and it becomes the feedstocks for the microorganisms that will then go and feed the salmon down the road. Now, how much of that is it's easy to take it from water, dump it, in the floodplain. Is that a good or bad thing? But that actually happens in the riparian nut
Mm-hmm.
habitat,
Mm-hmm.
something like that. So I just think that you want to look at this construct of what nature actually provides first and see what the application is.
Mm-hmm.
That because every process is a chemical process, a biotic process, and then the biotic relationship, especially with the biggest consumer, biggest organism consumer in the universe is microbes. Can we feed microbes in a way that either commercial or natural or whatever? So
Right.
conceptually, that's
Yeah. Well, on some level, the compositional analysis of the hull mirrors the fact that it was once a food product. And that is why dairy feed is what it is, and why there's poultry opportunities and why there's food grade ingredients is ultimate that evolution that created a hull that was more than something as a waste product. It had intrinsic value in terms of its composition. I think it's funny, I was talking to a grower over at the poster session before I came up here about the high potassium levels in the hull and could that be used as fertilizer. And ultimately, it's a cost part is going to drive that. Until we have technology that has in orchard hulling that would occur during the harvest process, which is a whole nother engineering of our harvest equipment, which we're already engineering to be off ground at the moment. So until we have that, then cost drives everything, and that's a lot about what you've analyzed for us. Is we can come up with a lot of ideas, but if moving hulls and shells is very expensive. It's a bulky, awkward, and weighty product, and getting your almonds to the huller and sheller and then paying to haul back your hulls. And then maybe you had to process them in some way so that when you applied them, if you're currently harvesting conventionally, you're applying it and you want it to not end up in next year's harvest in your windrow. So lots of phases of this journey, but definitely I think ultimately we're looking at the intrinsic value of what nature gave us and how to tap into that. So fully agree. Well, all ideas are still on the table. And as we look at some, if they don't pan out, we'll circle back and come up with new ones. So definitely. Any other comments or questions? Yeah. Right. Yeah. Well, I'll start and then you can jump in, Mark. So, definitely, the air quality issues reign supreme on torrefaction. So, whatever processes that we fund research on and or try to set the stage for public investment and commercial investment are going to have to meet our very strict air quality So exactly what that looks like, I don't know yet, but we will, with Richard Waycott, our CEO, and Julie Adams, I was part of a meeting with the Secretary of Food and Agriculture and some folks from the governor's office yesterday to talk about that. I brought up torrefaction a lot, so we are on their radar, and of course that's a technology that goes well beyond almonds. There's a lot of agricultural biomass of the woody nature in the Central Valley. Lots of vines, a few other trees. So whatever we can do that will unleash that, we'll figure out what those barriers look like, other than the grass, food safety that we talked about. As an example of where I would sort of say whole orchard recycling is a great example, where what really drives that adoption now is the fact that we're eliminating ag burning in the San Joaquin Valley. And thank goodness there was some foresight by a cooperative extension specialist, and he eventually convinced the committees at the Almond Board of your peers that we should fund that research, and at least now we have a viable option for our industry. Yes, it's costly, but we've also unleashed multiple public incentive dollars for growers to help offset that cost. So that's an example where it was the regulatory that drove it, that innovation, and so we were able to help develop more tools to meet the regulatory standards. But I don't know if you wanted to give some examples from your experience.
The regulatory community has prescription methods that you just follow. And when the prescription methods have to be applied to something new, you get together, you work together, you come up with a reasonable solution. I mean, the chemical engineering is there. We also, keep in mind in my torrefaction example, about over there in that process, right, you're gonna have something that has to go to either the water or the sky. You put the right environmental abatement equipment, which is prescribed to do that, and it's fine. So the trick is educating people on the details that actually take care of the environment from these processes. You know, chemical processes are big and scary, right? But if you educate people on, oh, okay, I see what you're doing, that makes sense. And the regulators have good intention. Now, sometimes somebody has whatever, political axe to grind or whatever, and you gotta work through that. But most times, and we have permitted things in California, we permitted a mine in California, 32 agencies. It's operating, it's permitted. We've permitted exhaust in Bay Area air quality management and South Coast air quality management, which are very difficult. But it's prescribed, it's reasonable people, you get together and you work it. Does it take time? Yes. 2 years. You know, so you've got to, once you get the go, for funding, you kind of have to almost pre-fund your permit effort. But that's okay, that's all part of the game. You know, I don't want to say it's easy.
Cost, yeah.
And I don't want to make light of it, but it's known. It's not really a risk. You know what I'm saying?
Great. Any other comments? Yeah.
Looking at the end-to-end production cycle, talking another acronym, life cycle assessment or analysis, depending on who you talk to, and looking at the R&D and commercialization of this, do you see with some of these concepts being introduced and delivered with these healthy plant-based alternatives, as far as the carbon footprint of even developing carbon black activated carbon being reduced, that was mentioned a little bit earlier, but as far as that, you know, your emissions, your input costs going down to a certain degree, how do you really see that factoring in and talking with Matt said earlier, you know, in terms of taste being number one, the big thing, and then the sustainability where that fits in, the value of the supply operations, but then taking a step back and looking at that carbon footprint and how this is morphed in, are there additional items we've seen in the European Union, or the major export market, you know, with these eco scores being piloted out in some of these countries? France is generally at the front of a lot of that, and some other nations, but do you see that being another subset selling point in this R&D commercialization standpoint in the LCA
If you guys want to weigh in on that, sort of
Yeah.
on the food side, definitely.
Definitely. And I'm going to speak mainly in the food waste space because that's more my expertise. But we do definitely see that being a driver, specifically with companies trying to meet their waste minimization goals and the U.S. Food Waste Champions of 2030 having that deadline quickly approaching. So while taste is king, like you pointed out, if they know that they can do ingredient swap outs that help reach that goal, it's definitely on the table and looking at reformulation or even different brand innovation to how they can kind of renovate either existing products or bring new products, and they can quantify, hey, we're substituting out 20% of our flour for 20% of almond ingredient. And if we're talking about a powder, it's not the weight of the powder. They're actually backtracking all the way to the weight of the hulls initially, reducing it down to the powder. So in different examples of, say, like a fruit pulp powder, you could be using 5 grams of powder and diverting 2 pounds of waste. And those numbers help hit those predetermined targets, and consumers are savvy now to that. They're looking, especially younger generations, and looking to, one, poke holes in companies that aren't meeting those goals, and two, applaud the companies that are and that are doing this innovative. So it still needs to taste good because someone could purchase a product off the sustainability messaging, but you're not going to get that reoccurring purchase. That needs to be there, but they're going to go to your brand in the first place because of these sustainability messages, because you're actually doing better to reduce waste, to meet these, be plant-based, do better for the environment overall.
Yeah, and we had a session yesterday on carbon, and Danone was one of the companies that spoke about their global commitment to reducing their carbon footprint, and they're looking to do that by insetting. So within their supply chain, you know, they can work on their own operations, but for many food products, the largest part of the carbon footprint is the ingredients that go in before it even gets to the company. And so they're looking at ways to work with suppliers to either swap out or to get a lower carbon footprint in the ingredient. And if something like almond hulls can add to maybe the already almond, which has a good sustainability footprint, then that is a value proposition that perhaps enhances, so long as you meet the other standards of taste and so forth. So that's our hope. So I think I'll go ahead and close the session with a few reminders. So the experts that you've heard from are available to talk right after the session. I think that's a safe guess. And we have a lot of information behind this little snapshot that you've heard today. So if you're at all interested in a little bit more depth on the economics or the compositional stuff, very happy to share that analysis in more depth. You can talk with the consultants who are behind it. I can share the report. We have some great research projects that are all publicly available information. You paid for it, and so you can have it. Definitely feel free to contact any one of us if you'd like more information. We're here to try to get this information out into the industry and to people who can use it as we develop it further. Logistically, if you're going to participate in the gala tonight, the doors open at 6 o'clock for the happy hour or cocktail hour. And then dinner starts around 7. If you haven't purchased a ticket, I'm sure there's space, so please go down to registration and purchase a ticket. And that concludes the substantive part of the Almond Conference this year. It's great to see you here. It's so rewarding to be able to interact in person again. So thank you for making the trip, and safe travels home. Thank you very much. Thank you to our speakers.